Hey guys, we're in Unit 7. This is day 2, and we're going to be working with explicit sequences. Our explicit formulas are the ones that are given to us on our reference sheet. So we can always refer to those formulas. Okay. So if you take a look at your reference sheet, when they tell you the arithmetic sequence, and it gives you your formula on your reference sheet, and the geometric sequence is also given to you on your reference sheet, those formulas are explicit because they can find any input or output can be determined from the formulas. Determine if you're given an input or an output, okay, and then put the value in the appropriate location in the formula, okay, and then solve for the other missing variable. Okay. Don't forget that because this is a formula or an equation, that it can be put into y equals to get a table and to verify your answers as well. Okay. So in number 1, they give us a sequence. Okay. And they're asking us to use the formula in order to find the first 4 terms of the sequence. And so remember that the first term is called a sub 1. Okay. And a sub 1 means that your n value is 1. And so when we clean that up a little bit, 2 times 1 is 2, and 2 minus 1 is 1. And so our first term becomes 1. They want us to find 4 of them, so we're going to have to keep going. So if we want to find the second term or the next term, we plug in 2. Okay. And we'll clean it up. And that's 2 times 2, which is 4. 4 minus 1 is 3. And so our second term of our sequence becomes 3. Okay. To find our third term, we'll make our n value, we'll make our n value 3. I accidentally made that say 3, but we don't want that to say 3. Okay. We still want to use the formula where there's a 2, and then the n value becomes 3. 2 times 3 is 6. 6 minus 1 is 5, and so our third term becomes 5. Okay. And they want us to find the first 4 terms, so we have 1 more to go. So we'll plug in 4 for n. And our fourth term comes out to be, 8 minus 1 is 7. And by using the formula, we just generated our sequence. So our sequence now looks like this: 1, 3, 5, 7, and then our sequence will keep going. Okay. In part B, they want to know which term has a value of 53. Which term? So we don't know the number plugging in. We know that if it's the first term, we plug in 1. If it's the second term, we plug in 2, and so on. But we don't know what number we're plugging in to figure out 53. So that means 53 is our output then. We don't know what to put in, okay, like in part A. So what we'll do is we'll put the 53 in the output spot, okay, which is a sub n, and we'll keep this n so that we can go ahead and solve for n. Okay. All we have to do is go ahead and add 1. That's going to give us 54 equals to 2n, and then we'll divide by 2, and n will come out to equal 27. And so it's the 27th term. Okay, so 53 is the 27th term. So had we put in 27, out pops 53. Part C says, why will there not be a term that has a value of 70? So let's go ahead and find out. Okay. So we'll go ahead and say 70 this time is our output. And we want to find what term we can go ahead and put in to get that 70 to come out. So we'll go ahead and say 70 equals 2n minus 1. We'll go ahead and add 1. We get 71 equals to 2n, and we'll divide by 2. And n will come out to be 35.5. So it'd be the 35.5th term. Does that sound right? No. And that's the reason terms have to be whole numbers, okay, or integers, and 35.5 isn't. So we can have a 35th term, we could have a 36th term, we can't have a 35.5th term. All right, so we can only have a 35th term or a 36th term, but we can't have a half term. So no half terms. Okay. Same thing, we can't have a zeroth term, we can't have a negative term, we can't have a half term either. All right. Let's go ahead and see what Part D says. Part D wants to know, is this arithmetic or geometric sequence? And identify 2 ways you can determine this. So going back up, remember our sequence is 1, 3, 5, 7 that we came up with in Part A. And so you can see that to get from term to term to term, we have to add 2, add 2, add 2. And so by adding 2, we can go ahead and say that this is arithmetic. Okay. And they said identify 2 ways that we can tell. And so one way we can tell is that there's a common difference. Or a number that is adding. So we add 2 to get from term to term. That's one way we can tell. The second way we can tell is that the formula that we have, called a sub n equals 2n minus 1, this is linear. And arithmetic sequences model linear functions. And so that's our second way that we can tell. All right. So let's take a look at number 2. Number 2 says a sequence is defined by, and they want to know the first 4 terms of the sequence. So same as what we did in the first one. We want to know the first term. Then we're going to go ahead and plug in 1. Okay. And if we type that into our calculator, or we do that by hand, 1 minus 1 is 0, 1/2 raised to the 0 power is just 1, and 80 times 1 is 80. And so that becomes our first term. All right, they want the first 4 terms. So now we're going to have to go ahead and find the second term, which means we're going to go ahead and plug in 2. And when we calculate our second term, it comes out to be 40. Now we have to find our third term, so we plug in 3. And we could type that right into our calculator, and out comes 20. All right, we want to find one more term, so we plug in 4. And we plug that right into our calculator, and out comes 10. And now we have our sequence, and our sequence would be 80, 40, 20, 10, and it would keep on going. Okay. Part B says which term has a value of 0.625. And so we don't know what to plug in. If we did, we would plug it in as the input. So we have to realize what they're giving here is the output. And so we have to make sure that we put that in the output spot. So 0.625 goes in the output spot. And we keep the rest of the formula. Now we have to realize that we're solving for n, and n is an exponent. All right, so because we're solving for that exponent, we're going to need logs. However, I don't think we're ready for logs yet. We have our base, which is the 1/2. We have our exponent, the n minus 1, and then our number. But 80 seems to be an extra here, so we're going to go ahead and divide by 80. In our calculator, 0.625 divided by 80 is going to give us an ugly decimal there, but if we math frac it, okay, or you could leave it as a decimal, it doesn't matter, is 1/128. Okay, and that's equal to our base of 1/2 raised to the n minus 1. Okay, and now we're going to go ahead and use logs. So we're going to go ahead and say log. My base is 1/2. My number is that decimal or the fraction of 1/128, and that's equal to n minus 1. Okay. Remember to put this into our calculator. We change it into a division problem. So we have log of 1/128, or the decimal, and log of 1/2 on the bottom. Remember, the base goes in the basement. Okay. If we type that into our calculator, we end up with a nice number of 7 equals n minus 1, and we'll do one last step of adding 1. And n's going to come out to equal 8. And so it's the 8th term. Okay. Part C wants to know, is this an arithmetic or a geometric sequence? So if we go back up and remember our terms are 80, 40, 20, 10, and so on, that to get from term to term to term, you're going to need to multiply by 1/2, multiply by 1/2, multiply by 1/2. And because you're multiplying, we're going to go ahead and say that this is geometric. And there's 2 ways to tell, because there's a common ratio which remember a common ratio is a number that you multiply by, and we're multiplying by 1/2. Okay? And the second way of terming is that, remember that our formula is exponential because your exponent has the variable in it. And so we can go ahead and say that b sub n equals 80 times 1/2 raised to the n minus 1 is exponential. And remember, exponential functions are modeled by geometric sequences, or we say geometric sequences model exponential, either way. Okay? And so there we go. All right, I'll see you guys on the backside of notes.